Hi everyone, welcome to my YouTube series, where we will dive into learning Go hands-on by building something both practical and impactful, a scalable CLI tool tailored for DevSecOps workflows. I'm Michael Taiska, a lifelong learner, a builder of scalable solutions, and a passionate advocate for sharing knowledge. I'm not here as an expert, but as a fellow explorer in the exciting world of Go, Kubernetes, and DevSecOps. In this series, we're going to tackle real-world challenges by building the CLI tool step by step, starting with the fundamentals of Go and growing our skills to advanced concepts like concurrency and networking. It's the perfect language for building fast, reliable, and scalable tools for the modern infrastructure. We'll start by building a CLI tool to handle common tasks such as scanning, logging, and validation. Then we'll progress to a more specialized project, an automated compliance and security validation tool for CI/CD pipeline. Let's talk about the problem we are addressing. Ensuring compliance with standards like SOC 2 or GDPR within a CI/CD workflow is tough, especially as the pipeline grows in complexity. Most teams rely on scattered or manual tools, which lead to inefficiencies. Issues like hard-coded secrets, unscanned dependencies, and misconfigured Kubernetes resources often make it into production due to lack of automation. Compliance and security processes often slow down development, causing friction between DevOps and security teams. Tools like Checkoff or Sneak are great, but can be expensive or require heavy customization, especially for startups or small teams. By the end of this series, we'll create a prototype CLI tool that can detect hard-coded credentials within the file, use tools like Trivia to find vulnerabilities in container images or libraries, enforce best practices like required labels or secure RBAC configurations, and create actionable compliance and security validation outputs. We're starting small but dreaming big. In later episodes, I'll show you how to extend the CLI tool to a Kubernetes native operator for live compliance monitoring. If you are a startup founder in AI, SaaS, or cloud native companies, this tool might resonate with your growing infrastructure needs. This series is your opportunity to see how real problems are solved in actionable ways. But here's the thing, this isn't just a teaching series, it's a discovery journey. I want your feedback, your insights, and your challenges to shape this tool into something practical, something valuable, and ultimately something you'd want to use. While I'm passionate about building scalable solutions and exploring the intersections of Go and Kubernetes, I'm also deeply committed to sharing what I've learned so that others can build smarter, faster, and more confidently. So whether you're here to level up your Go skills, tackle real-world DevOps challenges, or just explore how to build scalable tools, hit that like button, the subscribe button, and let's dive in. So this is going to be a quick video on how to get started with Go to install it. If you're using Windows, you want to use, and if you have a Mac, you can either download this and just run the install on a Mac, like it'll be a DMG file, or you can do, another way that I did it was to follow some steps they're using Brew. And if you just Google Brew, like Google how to install with Brew, it'll be really, really simple. You want to update your Brew. Let me just kind of show you some steps. If I'm able to. And so if you want to use Brew, which is what I did, I normally use Brew. I want to update your Brew, or Brew install Go, and then check your version. And you might need to set up your environment. You can use Nano, you can use whatever you want to use, but you want to export this out, and then you want to source it, and then that's pretty much it. So the first thing we want to do is go to your terminal and create a new folder. I've already created one. Then we're going to run this command go to the root of it and run this command go mod init github.com / your username, and then I'm gonna call this project this CLI. So this will create a go mod. It's just a module. So the first directory we're going to create is called one hello world. Create it like that. And inside here, we're going to create our main.go. And then this is going to be the first program that we actually create just to get our hands dirty. And every new main file or every new section, we're going to run manually and create a new main.go just so we get the feel and get the hang of running go and making go files and running go commands. So package main, and then we're not going to import, we're just going to let it import itself, and it's a main func. And then we're going to say fmt, and this will import the correct package. And we're going to say print line, and we're going to say hello CLI. And I actually should have put the name instead of hello world, hello CLI. Then we want to go and run that. Go and go. Say go run main.go. And we'll get hello CLI at the bottom of the screen. All right. So now we're going to move on, and we're going to create a new folder called one basic. Oh, this other one should have been 0. That's fine. I can unchange it now. Data types. Data types. Let me change that now. And then create a main.go again. Main.go. And do the same thing. Package main. Now that you wrote it, you can just start importing it. You can do it. You can get inside. You can let it import on its own. And the first thing we want to do, we don't actually want to create the main.go inside of here yet, because we're going to have a lot of different basics. We want to create one called one basic types. Types. Just follow me. I know it may not make sense, but just keep following me. Main.go. Let's close this out. And then we want to package main, func main. The first one is going to be an integer. So in Go provides several built-in types categorized as numeric, string, and Boolean. And so the first one we'll create is the numeric type integer, and then we'll say var x int equals 10, and then we'll say fmt dot print line, and then we'll do x, and this will give us an output of 10. So we want to come here, we want to cd up, go inside of here, and go inside of that basic the first folder, and go run main.go, and we'll get 10. The next one we want to run is floating point, and we'll say var pi float 64 equals 3.14159, and then we'll say fmt print pi, and of course this will give us pi. Put well equals this 3.14159, and run main.go, and we'll get that new number. And these are just simple, but again, I'm going over all of the basics, so we won't have any stones uncovered or unturned, whatever the word is called. So complex numbers. So you can read more about it. Again, it was something new for me. I wasn't aware of it. complex 128 equals complex. And you would assume that you use this, but we go with this. And then we say 1 and 2. And then ft dot print line z. And this will print out put equals plus 2. And so now we run that. Go run main.go. Oh, go run main.go. And to I. Okay. And so now we move on to string. And this is a var message equals var message string equals hello CLI. And then again, FMT. And you already know what this is. I'm not going to waste time doing that. Go run main.go. And we get that printed out. And the last one is the bool. Var active bool equals true. FMT print line active. And we get true. So that concludes the basics. Next one is going to be constants. So you want to write inside of this basic folder, we'll say to constant. Close that up and we give it a main.go. Let me close up some stuff over here in my other screen. It's confusing me. And we want to do the same thing. So package main func main. And then we want to say const version. Yeah, so version 1.0.10. And then we say FMT print line version. We want to cd up and then go to constants and then go run main.go. And we get that. All right, so that was really simple. We're going to create a new one called variables. Package main, func main. And I want to create a var count. So this is one way of doing it. You say var count int. And then this FMT print line count. Go run main.go. Oh, I'm in the wrong one. Oh, variables. All right, and we get 0. And the reason why is because it's default initialized to 0 if we don't add a value. All right, so we're going to say files, and we're going to do this colon equals, and we'll say 5. And now we're going to say FMT print line and files. And so what that does is just it's assigning 5 to files. So it's similar to doing count, this var, but you can do it files. You can do it this way here. So now we're going to go on to the next section. Can I create a new folder here? And this is for control structures. The first one we want to create is if I'm just gonna say if testing main.go. I keep want to call it main for some reason, but we're gonna first say package main, func main, and we want to say file path, this colon flag, and we import the flag dot string, and we want to say file, leave it blank, and then path to the file. So this is just a default, like it could be anything here to be honest with you. Flag dot parse, and then we say if the path to this file equals blank, and fmt print line error, no file path provided. Did I spell that right? Provided. Yes, I did. And then we're going to do os.exit1. Let's come this way. And we're going to exit with a 1. Then we're going to say if, and we don't need the first thing that comes from this, but we do need the error. And then we're going to say os.stat, and the file path os.isNot exist. Then we get the error from that. And then fmt print line error, file does not exist. And then we want to do the path, the path to that file path. Else, we want to just print out that file path. And then we say file exists. File path. And then inside of here, we want to create some random config.yaml. And we can just say app name, sample app, version 1.1.0.0. And this could be anything. I'm just doing this here. Settings, debug, true, max connections. And all of this is to lead us up to creating our own CLI tool that will read a config file and scan it to see if there's any vulnerabilities. Well, to scan it to see if there's any hard-coded values that shouldn't be there. So this is just exercises to like build us up to that point. 30, and then log file, logs app.log. And so now we need to cd to our path, control, and then go run main.go. And so no file path provided, of course. But if we do give it with a file path, we'll say go run main.go, file equals, and then config.yaml. And then we'll see file exists and it'll print us out there. So now the next thing we want to do is do another folder. For our next one is called if else, which we kind of already done if else, but we're going to take it a little bit further, okay? So if else, let's close this off. Go package main, func main. And then we say verbose colon equals flag dot bool. And then we say verbose. Again, these can be anything to start. We're just initializing it. False to start. Enable verbose output. And flag.parse. And then we say if verbose, then we want to fmt.print verbose mode enabled detailed logs here. Else fmt.print verbose mode disabled showing minimal logs. Say go cd back up and we'll say if else, and then we'll say go run main.go verbose. And so it's enabled, and if we don't run it with the verbose disabled showing minimal logs. So that's why we run that. Okay. Next we want to run a switch statement. So we call it switch. Main.go. Let me close out some of this stuff. And we do need two other files, but we'll put those in a minute. Package main, func main, and then we'll say file path. Let's call it equals the same thing that we ran earlier. So you can actually copy that code, but just to get our muscle memory going, you might want to just write it again. File path to file to the file. Flag.parse. And then we want to say switch. And it's similar to how you do switch in any other language. Say case strings dot has suffix. And what we're doing is we're seeing that if the file that we'll be creating, we'll be creating two files. If it ends with a YAML or like a short form of YAML, then we'll do this. Or if it has a JSON file, then we'll do that. Or we'll do a default. So the file, so we do reference to that file path. And then we want to say YAML, right? I think I'm missing, no, I'm not. And then we say strings dot has suffix, and then we'll do file path again, and we'll say short form YAML, and then we'll end it with that, and we'll say fmt print line, and we'll say processing YAML file, and then file path. Case strings dot has suffix. It's the same thing. This would be for JSON. Yes. Okay. So we'll say file path, and then we'll say JSON. Does it need to be? No, it's gonna be lowercase. You could do two of them, but I'm only gonna do one for this one. FMT print processing JSON file, and then the file path to that. Then the last case default, and and then we'll say FMT print unsupported. That's spell it right? Unsupported, yeah. File type. And then we'll print out the file path for that. All right. So now we come in and we go CD up to switch. And then the first one we want to run is run main, go run main.go. And then we want to pass in the file. Oh, we didn't create our files. My apologies. So we can just copy the other one from the first one. Could just duplicate that. And then for the JSON, if you want to, you can go to a JSON YAML converter, but I already have it, so that JSON. And then we will copy this in. I'm not going to type all of this. It's not that important. And all of the code will be in the description, so you can, in my GitHub, so you can get it from there. If you want to type this out, you can, but it's not really important. All right, so now we want to pass in a config.yaml and processing YAML file. And it gives us the file path. Did I do something wrong? Yes, I did. It's not this. Okay, there we go. And then so now we want to say go run main.go file, and then we pass in the config.json, and it's processing the JSON file. And then if I just don't pass anything in, it'll give us a default unsupported file type. Now, the fourth one is the loops, the basic loops. Basic loop, main.go. We say package main, func main. And then we're going to say for I colon equal 0. And this is very similar to any other for loop in any other language. I++. I can't write I++. And then you're just going to say FMT dot print. We're going to do print F this time. We're going to say scanning files %D. Then we want to inline in that line, and then we'll do the I+1, and then CD up, go into the for loop, and then go run main.go, and we'll get the print statements out for that. And we want to now create a new one for range. So this is a range loop. Can I spell? Main.go. So let me read some. So the basic for loop is the most versatile looping construct in Go. It works similar to for loops in other programming languages like C or Python. This loop is commonly used when you know the exact number of iterations you need to perform, or when iterating based on a condition. So that's when you use a basic for loop. The range loop, the range keyword in Go simplifies iteration over collections like arrays, slices, map, strings, and channels. We'll go into those a little bit later. It automatically provides the index and the value for each element in the collection, making it ideal for iterating over dynamic or predefined collections of data. So as this says, the difference between a basic loop is you use the basic loop when you already when you already have like a predefined set of numbers iterations, and you use the range loop when you want to use a dynamic form. So if you want to iterate over the number that's defined in the collection without you having to define it. So now we want to come in, we want to say package main func main, and this is going to be the last one. I have to step away, but I will be back. We'll say files, and we'll create an array of string, and we'll give it main.go. Can't spell go, man. And then we'll give it another config.yaml. So these could be anything. It's just making an array of just some random stuff. Config.json. And then we want to say for index file in the range of files, which is the array. So now we're using the range, and this is dynamic because we're iterating over the range of what's in this array. So 0, 1, 2. And then we want to say fmt dot print. We're doing printf this time again. Printf. And we'll say file %d %s, and then we inline. Then we do the index +1, and then we do the file. And so now cd up to a that's folder and go run main.go. And now we'll iterate over those. So let's quickly do this last one for this section, which is the infinite loop. An infinite loop is a loop that runs indefinitely or until an explicit conditions break it. Condition breaks it. This loop is often used in server applications, event-driven systems, or scenarios where condition processing or monitoring is required. So in other languages, you have like a do while loop or like a while loop. This is what that is. You have some condition that you want the loop to continue doing until it meets some condition. So we want to create that, and we'll say indefinite loop. Indefinite loop. I think I spelled that wrong. Let me check. Yeah, I think it's right. That's fine. So we're going to say main.go, package main, func main, and then we want to say a count. So this is going to be our condition variable. Count, going to initialize it to be 0. And then we're going to say for, and then we do a condition inside. If count equals 3, then we'll fmt dot something happened. Fmt dot print finished processing, and then we'll break the loop. Fmt dot print line, and we'll say processing. So it'll continue going until the count is looped, and so we want to iterate the count, increment the count. My apologies. Cd up, go run main.go. Cool. And so we went over it 3 times, and then it finished processing. So that was it for the basic section. We went through the basic types, the constants, variables, control structures with ifs, if else, switch statements, the basic for loop, the range loop, and the indefinite loop. In the next video, we will go over functions, and then after that, we'll continue on with methods, and then we'll go into composite types, which will include arrays, slices, and whatever else is within a composite type. All right. Thanks for watching. Stay tuned for the next video. So I'm recording this for the second time. Just realized that I wasn't recording my screen for a whole hour, but we're going to do it again. So this section here is for functions. It's on functions. Let me give you a quick overview of functions. So functions. In our CLI tool, functions are the core building block for the commands like scan, validate, and report. They encapsulate specific operations, making the tool modular, maintainable, and scalable. So we're going to go back to our code. We're going to create a new folder, name it 2, and we're going to call it functions. And then 2, we're going to create a new folder inside of here, call it 1, function as parameter. Well, let me see if that's the right one. No, so this is just a basic function. Basic function. All right, and let's do our traditional main.go, and we do package main, and we do func main. And if you don't already know, main itself is a function. That's what we call it, func main. So let's start with our first function, and it'll be called func validate, and this should be lowercase validate path, and it accept a string called path, and return an error. And let's check if the path that passed in is empty. And if so, return dot error of path cannot be empty, cannot be empty. And then now we want to return nil. So if we turn the error, well, so if it is an empty, then we will return an error, which is this. But if it's not empty, well, then we'll just return nothing or nil. And then so now in the main, we're going to say path equals in some random name you can give it. And then we'll say if error. So we'll get the error from this validate path that it will return. We pass in the path that we just defined, or if error equals nil. One L. And then we say format.print line this time, error, and then we print out the error. Then we're going to return it. We're going to return to break out of the condition. Print line. Path is valid. So CLI functions, and then we say run main.go, and what is it asking me for? Okay, no such file directory. This the right one? No, this is not it. Basic. Oh, we need to go inside of basic. That's why. Run main.go. All right, so the path is valid, but let's say if we didn't simulate an error, path will be empty, and now we'll get this path cannot be empty. So that's how you run that. It's very simple, and if you're coming from another language, whether it's JavaScript or Python, it's the same. Now let's go to functions. So a function can have functions are flexible and support various use cases, including functions as parameters. And another one's called a Variadic function and anonymous function. So next we're going to look at for a function as a parameter. So this here was just a basic function. The next one we're going to look at is called function as params. We're going to say params. And then we'll do main.go, close this up, and then we'll say package main func main. And so now we're going to use an example of a scanner function. So we're going to create our type, and it'll be a scanner func. It's a function, accepts a file path. I don't need that file path, which is a string, and it returns that. It returns a report string and an error, which is of error type. So this is our type. So now let's make a function that aligns with that type. Run scanner, and it will accept that scanner, which is a scanner function. So it accepts a function of this type, because this is a function that accepts a string and returns a report string and an error. And so we want to have this be defined by that type. So we'll say, and it accepts a file path string. And we say report error. That's a report, right? Yeah, report error. And we want to say scanner. So we're going to use this function here, and we're going to call file path, this path here. And then if error is not nil, meaning if there is an error, we want to say format dot print line error. Then we want to break out of that. So by returning, then we want to say else print line scan report, and then the actual report name. And then here is the function that we're going to use. So this scanner function is of this type, but the actual function that we're going to use is called function secrets scanner, and we got to abide by this. So it'll be file path, which is a string, and it returns a string and an error. And say no secret found in file path, and then nil, because it's for the error. So this is the file path, which is a string, and this is the nil. All right, so we could have another one. I'm just gonna make a dummy. Let's scan secret scanner. Let's I don't know another one off the top of my head. Let's just say validate YAML. I don't know. And then secrets found. YAML is valid. It's valid. YAML is valid. I don't know. So all right. So now here we could run that secret scanner, and we pass in a secret. Pass this function in. No, my bad. We want to run this run scanner, pass in this function here, and then pass in some dummy file name, config.yaml. And if we run this, go up, function as parameter, go run main.go. No secrets found in that. And then if we want to run this next one, let's just comment this out. We'll say run scanner, because they both conform to the same type. We can say validate YAML, and then, some config.yaml, and run that too. YAML is validating, and this is the file path. So that's pretty much it for accepting a file path. So let me run through it again. Basically, we passed the function as a parameter. This is the function here that runs it, but it accepts a function as the parameter, and this function itself is going to be the scanner, which we pass in whether it's the secret or this. So this function gets passed in along with the file path, and it uses this file path to do some logic. And that's pretty much how it works. I'm kind of breeze through these because I just spent the whole hour doing it for nothing. But if I'm skipping over something by mistake, just let me know in the comment section and I'll get to it. The next one is going to be Variadic Function. So we're going to create a folder 3, Variadic Function. And we say main.go. Package main, func main, and then we will say create this function called func validate files, which accepts a path. And so let's read. Variadic function allows you to handle a dynamic number of inputs, which is ideal for batch processing. So basically, we can handle a dynamic number of inputs, and you will see how that works. So we have this paths, and it could be a dynamic number of strings that we don't know in the beginning, right? And so it accepts a dynamic path strings, and it returns an error. And then we say for path in a range of paths, if error validate path. So let's create a func validate path string, turn an error if path equals empty, then we need to return an error, so we're going to say format dot error of, say path cannot be empty. Did I spell it right? Yes. Okay, and then we return nil. And so here we say validate the path. And then we pass in that path here. And then an error equals nil. Okay, so return. So if the validate path, and if the error is, if it's not equals nil. So if there is an error, then we return this error. And then we say, print this out, return FMT, error validating, and then we say S, and then W, path error. And then now we return nil. And then now here we can call it, say error, validate files. And we're going to pass in some random file names or file paths. One YAML files 2.yaml. And these could be anything. Files 3.yaml. And then we say if error. Then we want to print out that error. Validating error. This should be a comma. And this should be a comma. Else dot print line, all files are valid. And then let's run this. And so basically we have these three files, and we're going to pass them into the validate files, which accepts an dynamic number of inputs, and we can see those. So go run main.go. All files are valid. So that's it for that. The next one is going to be anonymous functions. Anonymous functions are useful for ad hoc operations such as filtering or customizing logic in a pipeline. So let's look at an example of that. I want to make sure I was recording. All right, so for anonymous function for your NCTR. And then main.go, package main, func main. All right. So here we are going to, let's look at this. We're going to have a func process results, which accepts an array of results, an array of strings, and a filter function that has an array, that accepts an array and returns a bool. And this entire thing returns a string array. And we say filtered is an array that's empty for now. And we'll append some stuff in a minute. And we say for, and we want to get the result. And the range of results. And say if filter, and we pass in that result. And I will explain this in a minute. Just filter.append, and we pass in filter and result. And for here we return filter, return this array. And so now results is in a string. We're going to pass in pass. This could be in anything, but for this use case, I'm just make it 2 passes. And we say only passes. So we want to only get the passes. So now we say results. And we're going to pass in this as, that's fine, like that. And then now we say return if s equals pass. Now we say fmt dot print line passes, only passes. Now let's run this, and again, I'm gonna go over it in a minute. So let's come in functions, anonymous function, make sure go run main.go. So we get back to two passes. So the way this works is it uses an anonymous function. So we have an array of results. We have passes, two passes and one on failure, and then this uses this function here, and we take the result. So we pass in. So again, so this function here accepts an array of strings. So we pass in this array of string, and it accepts a function. We pass in an anonymous function, and this anonymous function, as we see here, accepts a string array, and it returns a Boolean. So we pass this function in here, which aligns with this. So this here whole logic is the function that we're going to execute inside of here. And it's going to take this filter, and it is going to filter right here. Yeah. So for each value in this array, and each value in this array, we're going to filter it by the results. So the results that we pass as in is this here, this logic. If s equals pass. So we're going to pass in the result, each value was passed, and does it, this equals pass? Yes. If it does, then append it to this array here that we, append it to this array. So if it passes this logic, which it will on here and here, and then we append it to this array. That's pretty much it. Just pretty simple. Just kind of look at it, run it, and then you'll get the hang of it. So that's it for the functions. The last thing I think I want to cover, or I might wait for the next video. Yeah, I think I'm gonna wait for the next video. The next video, I'm gonna go over the defer. All right, that's it for this video. I hope you found it helpful. Stay tuned for the next video. Thanks. All right, so to wrap up this section or this chapter, I want to finish this chapter off with the final section, which is defer. And we're going to add a folder to, now let's go, to here. I'm going to call it 5. 5, defer. Come in and create a new folder called 1, basic. And then we want to do a main.go. And then, as usual, package main, func main. So let me kind of start with what is a defer. In Go, the defer statement schedules a function call to be executed just before the surrounding function, the function which the defer is written. It returns regardless whether of how the function exits. This behavior ensures that the critical cleanup operations like closing file handles, releasing locks, or cleaning up temporary resources are always performed, even in presence of an error or unexpected conditions. For developers familiar with languages like Java, Python, or C#, defer in Go is conceptually similar to the finally block in a try-catch finally statement. Both mechanisms ensure the cleanup logic is always executed, regardless of how the code within the block or function exits. I'm going to create this a function called func scan file. It accepts a path string, and it returns an error. We have file error equals os.open. Let that import, and then we'll use the path. And then if error is nil or is not nil, then we do this. We're going to return fmt error f. I was saying error of, but I meant error f. To open files. And then we're going to have this error. So and then I think that's it for that. Then we're going to say if error process file. Let me write the process file to function. Process file. Pointer to os.file. And then it returns a error. Then format print line and processing file. And then we say file.name. And we return nil because we don't want to return any error. And then that's it for that. And so if we come here back down to this, we can use that. So now error, and then we say process file, and then we pass in that file that we have here. And then we want to do error if not nil, file.close. And so like this is an example of how we would close a file without using the defer. It's not the best way. So like this is like the not optimal way of doing it. And then we say file.close, and I'm gonna explain it to you in a minute. Turn nil. I'm missing. Okay. And then so now in the main, we want to use that if error. And then whatever we get back from example.txt. And we need to make this file too. Error. And then so I'm going to come in here and just make a example.txt in some file. All right. This thing is in the way, that's why I can't really see. So let me kind of read this. And again, like this is the not optimal way. I'm just going to put up there. Not optimal approach. And so what this does, of course, you can read it yourself, but we're going to try to scan a file, and to scan that file, whenever we open it, if there's an error that happens whenever we open it, whenever we're trying to open it, we're just going to return that error, right? So that's what we do. We return that error. But if we are able to open it and then an error occurs while we are processing it, then we need to close that file and then return the error. So again, so if we successfully opened it and then now we're trying to process it and then an error occurs, we need to close it and then return an error. Also, if there is no error while processing it and it processed successfully, then we also need to close that file again. Well, not again because it's the first time, but if you see there's a duplication, so if there's an error that happened while we're processing it, we need to close it and then return an error. And then if there's no error while we're processing it, we need to close it and return a nil. So this is how you would approach this if you didn't use a defer. And I'm going to show you why defers exist. So let's go run that. Go run main.go. And so processing file exists, and then let's say we don't have that file for some reason. Well, it won't even open it up, it just return an error. I'm not going to be able to mimic an error occur here unless I create an error and throw it, but that's not the point of this. The point is to show you the more optimal way by using the defer. So we're going to say optimal approach. I need to rush. I need to kind of hurry up and go. And so now we're going to do the same file, say func scan file. It has a file again. You should just copy that, but just to get in the use of writing this code, we're going to keep writing it out. And it returns an error. Format print line. Oh, what am I doing? So I'm doing the wrong part. So this has a file. A path, which is a string, and it still returns an error. And then it's a file error os.open. And we're going to open that path. Then if error occurs while we're opening that path, then we return format error f fail to open file v error. And then now we can defer the file close. And you'll notice that we only do this once. We only got to do this once. And so now we say format print and say scanning file, and then we say path. Then we return, did I spell it wrong? No, return processing file and send in that path. No, yeah, the file. And then, no, so that's it. So we just return that. And that's pretty much it. So if you noticed here, again, if there's an error that occurred, we had to close it. And if there's no error, we had to close it. Here, we only need to defer it once, or call this once on a defer, because regardless if it fails, we're going to close it automatically by doing this defer. And if it successfully works successfully, then we still close it, because this will run last. It's like the finally block, the finally statement in the try catch block, finally block. And so now if we run this, where's my cursor? Right here. We get the same thing. Scanning file example, I think I spelled it right, and then processing example. So that shows you how it works. And just to be clear, the point of this defer is so that you can put it on something that you want to like a cleanup. If you open up a database connection or something like that, you always want to run this. It's like the finally part. So it ensures the file is closed no matter how the function exits. It improves readability by keeping the cleanup logic close to the acquisition. Now let's do the next one. And sorry for sounding like I'm kind of speeding through. I'm gonna slow down. So let's do closure. And let's do main.go. And then we say package. Did that run? Was that the right one that I ran? And let's make sure. Yeah, it's still the same thing. For whatever reason, I think I made a change and it just didn't save on that. So, you know what else? Package, main, font, main, same thing. And so I'm going to show you a gotcha in this. Well, I'm just going to show you the closure in this gotcha, right? So say var count int, mean this by default would be a 0, right? And then we say defer f print f deferred value d, and then we say count, and then count is 42 ft dot print line main function exiting. And then let's go up to closure and go run main.go. And as we see, it exits. And I'm gonna close on. I'm gonna come back to this the order like last. But as we see, we get the main. It exits, and then we get the value 0. And so you may be wondering like why this shows a 0 when we clearly changed. So if you're probably wondering like, okay, so if this is the last thing that runs, why didn't the count actually go to 42 if we change the value here, right? And that is because the deferred statement. So the defer statement creates a closure over the local variables. The defer statement creates a closure over the local values it references. These variables are captured at the time the defer statement is executed, and their values remain unchanged even if updated later. So what that means is at the time that this is defined, or the time that this is captured, at the time this is executed, right? Well, at the time the defer statement is executed. So at the time this is executed, regardless, however I just read it, whatever, just ignore that. What it's basically saying is no matter if this is changed here, it won't matter because this value will always remain whatever it was when we defined it, because there's nothing that been updated because it's the local value. So locally here we are at 0. And then this, when we define this, it's still at 0. So whenever it runs, it's going to have the value of 0. So that is the gotcha, because, you know, when you're running this, like you may be running them in your project, you try to make an update and you'll wonder. I don't think you've run into this case, but just in case. And so the way you avoid this is, let's do another one. And we say font main. And I may not explain that clearly, but you will see the point, what I'm trying to say now, of how you can avoid this. Count, and we say fmt print initial value of count, and we say d in count, and then we say defer statement captured the current value of count is 0. So we capture the value here whenever we write this defer. So at the time when we write this, that's when it's captured. So captured count int. So it's an int that we're going to pass in. fmt dot printf deferred value percent D in, am I missing something? No. Capture count, and then we pass in count. So now we can pass that value in, and then at this time the capture value will be whatever we pass in. And so now we say update count after defer, and now we say count equals 42, and then we say fmt printf updated value of count and percent D in count, and then we say fmt print line this time, main function exiting. So the expected output will be this, right? So it'll be 0. That's the first thing that's happening. And then we'll see this 42. Then we'll see main exiting. And then lastly, we'll see the 0 again, because that's when it deferred. So this is the deferred value is 0. So this is what we expect, because we see this. We're going to see the 42, which is what we print here. So we print 0 here, and then we will see the 42 being updated. So we'll see updated, because this, my bad. See updated, which is this, because we updated it here, and then we'll see the main exiting, and then the last thing will be still the 0. And let's run this. Just push up. So we see initial value count. Did I not do something right? Initial value count. Read, look, oh, printf. Okay, that's why. Okay, there we go. I was missing the printout. So first we get the 0. And then we get to 42, because the next statement that runs after this doesn't run yet, is 0. It's 42. Then we get this, and then the final thing that we get is going to still be the 0, because even though we pass it in, it's still at the time of the capture, which is 0, because we initialize it here. Now, just to be, whatever, it doesn't really make sense. But if let's say we name it 33, now it should be 33 before deferred value. See, here the deferred value was 0, and now again, this doesn't make sense. We would never do this, but to show you that we can, whatever the value is here, whenever this is defined, that's the value that's going to be, shown. So I want to show for that. And the last thing, and it's kind of evident in this, but I just want to wrap it up in a new folder and just put in this new folder. And we're going to say LIFO. That means last in, first out. Package main. And then we say func main. And then we're going to say defer fmt dot print line deferred 1. I'm just going to copy this. It's wrong command. Deferred 2. And then we want to print line. FMT print line. Main function exiting. So the purpose of this is to show you that it like this is a LIFO. So like the first thing, so the first one that comes in is the last one that gets out, right? So the order that it should print out will be this, because the deferred is going to happen last. And then so we're going to say this will be the first thing to print. And then the last in, first out, LIFO. So the last in will be the first out. And so that means the last in should be the first out. So this is last. So we should see this, and then this, and then this, right? Go, run main.go. So get it. So main, exit first, then this was the last one, and then this was the first one. So last in, first out. So that wraps it up. That concludes. Was I recording? Yeah, good. Whew, I thought I missed it out. I did that today. So that concludes this chapter. We've covered quite a bit. I hope that was pretty, simple or, easy to grasp. If there's any questions, feel free to list them in the comments below. I will try my best to read all the comments and answer any questions. Thanks for watching. Okay, so let's continue where we left off last time, and we're going to pick up with the data structure. So let's create another folder. Make sure that it's in the root, and it's going to be 3, and we'll call it data structures. Structures. Okay, cool. Composite types in Go, arrays, slices, maps, and structs are fundamental for organizing and managing data in a structured and efficient way. In the context of our CLI tool, they provide essential building blocks for handling inputs, processing data, and generating outputs. So the first thing we're going to start with is the arrays. So let's create a folder for arrays. We're going to call it 1. We'll just make it lowercase. You can make it uppercase. It doesn't really matter. You can give it a different name too if you want, but main.go. And let's close all of these other files and package main, func main. So an array in Go is a fixed size collection of elements of the same type. While their size is immutable, arrays are useful for static data sets like predefined compliance rules. So an example of a simple array, and we've already seen it before, but let's just continue with the format. So we'll say rules. And then we'll make it a fixed type, a fixed size. So it's 3, and then we'll have, keep on the same line, no hard-coded secrets, use RBAC, and enforce resource limits. So that's our array, and now we're just going to iterate through it for a rule. Range and rules, and then we'll say format print F, and then we'll say rule %D %S new line, and then we'll just say rule, well, +1, and then rule, and then let's cd to that folder and go run main.go. So we get those rules printed to the screen. The next data type we're going to look at, the next data structure we're going to look at is slices. A slice is a flexible and dynamic abstraction over arrays. Slices are perfect for handling input data that changes at runtime, such as a user specified files or directories to scan. So let's look at an example of some directories to scan. Say package main, say func main, and I just put some initial list of files to scan. Then we say files. And if you see this here doesn't have the size, so that means that's what makes it a slice. Main.go deployment.yaml. Then files. So we're going to append, and then we're going to add config.json, then a service.yaml. And then fmt print line, files to scan. Then let's iterate over that. File, range of files. Print line, file. And then let's go with that. Go run main.go. And now we have it. We first started with go and deployment, and then we're simulating that at runtime somewhere. We added these new files, which we just appended, config and service. All right, so let's move on and let's talk about maps. So we'll say 3 maps main.go. Let's clear out everything. Package main, func main. So a map is a collection of key value pairs, making it ideal for associating data like file names with scan rules or validation statuses. So let's look at an example of storing scan results. So we'll say results, and then we'll say make. And we haven't seen this command make, but we'll go over this in a minute. But just for now, just keep going with me. It'll make sense. Add results. Then we'll say results. We're adding in key dot. This is the key, main.go. And then we're putting in the value for that key. It's similar to any other language. No issues. And then we can say it again. Config.yaml. And then we say secrets found. And then we iterate over that. File, result, range of results, fmt printf, and then we're going to have %s, and then another %s in the new line. Then we have file and result. And then let's iterate over that. And let's run that. So this is what we have. So for main, I spell main again. I actually keep spelling main with a G for some reason. Let's do it again. So for main.go, no issues. For config, secrets were found. Let's look at one more use case. Let's just comment this out and then do another one. Func main, and then we'll say files. This is just an example of how to detect duplicates, just because I like this example. Am I doing this right? Yes. Map. Okay, so string, yeah, bool. And then we say to scan. Fat fingering this stuff, man. Okay, and then this is an array, or a slice, I meant. Main.go. This shouldn't be inside there, it should be outside of this. Main.go, main.go, and config.yaml. So basically we have, what am I doing, string? Does not need to go inside of here because it's just a slice like that. So we have a map and we have an array, and we're going to find duplicates by iterating over this and adding it to the map in case we don't see it. And then once we get to it again, it's similar algorithm type of things that you've seen, sure, in your experience. But just want to do it. So range to scan, and then we say if files, and then if that file exists inside of the files, then we will print it out. Duplicate file, and then S, new line, and then just the file. Else, add it. So at that in files, which is this map, at that key, which is the name of here, we will add a true. So that just tells us if it's already inside it, then we'll just print it out, say it's a duplicate. Else we'll add it. So the first time it'll come, it won't see anything in this array. I mean, it won't see anything in this map, so it'll add it. Then the next time it come, it will see it in that same key, which is same name. You got to make sure the names are the same. And then if it sees it, then it'll make it a duplicate. So let's say go run main.go. And so it's a duplicate file found for main.go. So that was just something simple. The next thing we're going to look at is structs. So we want to come inside of here. This will be 4. And then we'll say main.go. Package main. Func main. All right. A strut is a composite type that groups fields together, representing an entity with multiple attributes. Struts are invaluable for modeling complex entities like validation results or compliance rules. So this is just a simple example of a strut. We will say, let's make some room. Let's make a type and say rule presents a compliance rule, and then this is a type called rule strut. Then we have name, and we'll just do it over two times, I think. Maybe that's too many. Yeah, that's probably too many, twice. And then we have description. Maybe it wasn't too many. String, then severity string. All right, so that is our strut, and now we can use that, and this should actually go outside of the main. And then we say rule equals a rule. And then for the name, we want to give it a value. Let's make no hard-coded secrets. That's one rule. Did I spell secrets right? Yes. Then add a comma. Then the next one is description. And then we say secrets such as API keys must not be hard coded in the code base, comma. And then the last one is severity. We need a colon right there. And then now we say description. Did I spell description right? I think so. What's the issue? I think, is that a colon? Comma. This one is not a comma. I can't see. Okay, and then we say hi for so why is this one unknown field severity? I think I spelled it wrong. Yeah. All right. And now we just need to use it. So fmt print f, and then we'll say rule %s. Then we'll make another %s inside of. Okay, and then on a new line, we'll do another %s, and then a new line. And then this will be rule.name, rule.severity, and then rule.description. All right, and then now let's cd to that, go run main.go. All right, and so we see the hard-coded secrets is high, and then secrets such as API keys must not be hard-coded in the code base, and I spelled the wrong. It's okay. All right, that's cool. Now, the last thing I want to discuss is allocation. And it took me, a few minutes to like wrap my head around this one. So I'm going to try to explain it the best, what allowed me to get it. So, all right. So in Go, memory allocation is handled by two built-in primitives, new and make. And we saw make being used a while ago. The purpose, okay, so new allocates memory for a value of a specific type and returns a pointer to it. So like this is a key. So whenever you allocate, you create a data structure, one of the four data structures that we just talked about, when you use the new keyword or the new keyword, what it does is it allocates the memory and it returns a pointer to that actual data structure. So you use new or make when you need like a shareable data structure. So you don't have to create your data structures with the keyword new or make. You can do it the same way how we just done. But whenever you need like a shareable data structure, so an example, like one example could be like in our pipeline, we may need to, have some kind of data structure that multiple stages add some data to. And so that's whenever you use the keyword new or make, because we need to be able to reference that data structure in those different stages and update the values as such, right? And another note is make is always preferred for maps, slices, and channels. We haven't discussed channels yet, but for maps and slices, it's appropriate to always use make, and new is appropriate for structs and arrays. So now let's look at an example of that. So we'll say package. And if none of what I just said didn't make sense, it'll make sense as I keep typing and showing you code that will try to make sure that you understand. Because again, for me, like it took me a second to like wrap my head around it. Like I didn't really understand it, but now I get it. So we're gonna make a struct config. We have name, and it doesn't matter like the spacing on this one. It's more about making sure you understand the concept. So config, and we'll make it with new because this is a struct. And then let's put a comment here. Allocates memory for a config struct. Okay, and now we'll say printf, and then we'll say default config, and then it'll be percent plus v, because this is a reference type, a reference to that pointer, and then we'll say config. All right, now we're going to update the fields. F-E-I-L. No, F-I. I had it right the first time. Config.name was example. Then config.port is listening on 8080. And then say printf updated config, and then we need to again percent plus v, new line, config, and let's cd to that application, go run main.go. All right, so as you see, we created this config struct with the new keyword, and it allocated the memory, and it returned the pointer to it. That's why we have to use this. But even though because it's a struct, it's immediately available to be able to use. So that's why we was able to update the fields, right? Now, the reason why this is possible with the structs is because the way Go handles structs is differently than how it handles other data structures. Go automatically dereferences the structs pointer for you, making it immediately available to use. That's why we was able to like use this without having to use the asterisk the way we normally have to reference like the pointers. So let me show you an example of if we would have done it differently, how we would get an error. So now we'll say func main, Then we'll say p new, and then we'll say it's a map string, and then it's an int. And then so because we're not using a strut, we're using a different data type, this pointer won't be immediately available to be able to be used. And that's why we have to use the asterisk. So we call it P, and then we say key, and then we try to update this value. So again, let me make some comments. This allocates the pointer to a map, but the map is nil, because whenever it creates it, by default it creates the default values, and so the default value for this is nil, and so this will cause an error because we're trying to update a nil value. So this will cause in runtime panic because the map is nil. So assigned to a nil map, so it won't even let us run it. I don't think. Let's see if we can run it. Yeah, so it gives us a panic because we're trying to set it to a nil value. Now, this is a correct but not appropriate way. Like it's not the right way to do it either, but it is the correct way. So we can say main, and I'm not gonna copy paste. I'm just gonna do it all over. Then we say new. So again, we're using that keyword for new. We're making that same map, string, and int. And again, we're allocating that. Allocates a pointer to nil map, which is what we have above. And so now, it doesn't really make sense, but you use make to make it. And so again, make will initialize it explicitly. That's why you want to use make with the other data structures other than, so like slices, channels, and maps. So you say map string int. So now this initializes it. Initializes the map explicitly. I think that's how you spell it. And then so now if I use the reference to that, I can say key equals 42. And then you notice I don't get the error like I got here. And so now, because now it's usable, because I'm using this pointer. And then I say ft print line, I say map value, and now I can and then let's try to run that. And so now we can see map value, and then we get the reference to where it's at. So again, this is a way you can do it. It's not the appropriate way, right? The correct way, of course, is to just use a map from the beginning. So we say, let me make this up, main. Then we say M. We just use make from the beginning because we're using a map. And then we say string int. And then we say now, because we use the make, it's immediately available to use. And we can just say key equals 42. I say 42. Let's say 44. I like 44. And then say print f. M is of type. And then print out the type and value the M. So what we're doing is, let's run and see what we get. It should output this and then this. Should output both of them. Yeah, so M is of type string because we are using a type, and the type that we have is a map string int, and the value, okay, did I spell it? And the value, let's do it again. The value is, and we get pointer to the pointer, which is this, right? Add 44 to the key. So let me say the key takeaways. For maps, slices, and channels, the new produces a pointer with zero value, a nil, which is not directly usable. So if you want to use maps, slices, you want to use the make keyword and not the new. If you want to use a strut or an array, you can use the new keyword. But again, you only need to use new and make these allocations if you are trying to create a data structure that you need to have like some kind of shareable file, because you're using pointers, so you can point to that data structure and update it. So again, in our pipeline, if we have some array or some object or whatever, like a map, and we want to update some kind of value at every stage, like a status or something, then each stage can point to that same data structure, the same map, and update it at different stages and share that same the same data structure without copying over. But if you just want to use it without having a shareable, then you don't need to use make or new. And that's pretty much, that was the takeaway that I took from all of this, and this is how you use it. So I hope this was helpful. This was a pretty short section, which is kind of good. We're breezing through. The next thing the next section we're gonna cover is methods, I believe. So stay tuned. Thanks for watching. All right, so in this next section, we're going to be discussing methods. Methods in Go allow you to associate behavior with specific types, enabling modular, reusable, and organized code. In the context of a CLI tool, methods help define the actions for components like logger, scanner, and CLI context. By leveraging methods and receivers, you can create a clean and maintainable design that simplifies command management for operations like scan, validate, and report. A receiver is a special parameter that lets you bind a function to a specific type, effectively turning a function into a method. This approach groups related functionality with types, promoting encapsulation and reuse. All right, so let's look at an example of how to use a method. So we're going to go back to our code. We're going to create a folder and it'll be called methods. And so inside of here, we're going to create another folder called, basic. So one basic. And let's close all this other stuff out. We don't need it. Create our main.go. And we'll begin with package main. And we're going to create a type CLI context, a struct. And we're going to give it a config path, tab 2 times, string, and then we'll say verbose. We should have just tapped once then. Okay. And then we say method to load configuration. And then we'll say func. And then LI context. And then remember to make it uppercase. Config. It returns an error. And the logic would be if c.config path is empty, then return format of error. Config path cannot be empty. And then here we want to say format.print line loading config from c.config path, and then we return nil. And then let's create our main. Main set CTX for context. CLI context. And then we're gonna give this, and these paths are not real. Just can make them anything. Verbose equals true. And we say if error comes from this CTX call, load context, load config. So if there's an error, then we're going to say format.print line error loading config, and then just print out the error. Else dot print, and we say config loaded successfully. Config loaded successfully. And then we want to run this. So let's cd up to, did we create the folder yet? Methods, where's methods at? Am I in the wrong one? So, I got to go up twice. Okay. And then one. Then go run main.go. So that's pretty much simple how you created it. But this is the method, and it's binded or tied to this struct. So that's why we can use it here. When we create this method is binded to this, so now we can call it, and it makes it easier to do it that way. So that's it for that. Let's move on. Why use methods with receivers? Methods provide a natural way to group functionality with related data. In our example, the CLI context, it makes it readable. It's more intuitive to call that load config instead of calling like a standalone function. And it makes it reusable. So now let's continue on to Nil Receivers. Go allows methods to be called on Nil Receivers, making it possible to handle edge cases gracefully. This is particularly useful when a component in a CLI tool. This is particularly useful when a component in a CLI tool, like a logger or a scanner, may not be initialized but still need to behave predictably. This avoids runtime panic that would typically occur when dereferencing nils, which we saw earlier. So if you remember, whenever we use data structures that have pointers to them, if they're not initialized and we try to use it, we get the panic error. So let's look at an example of how this works. So we say package main, and then we'll start with a type, a logger, verbose, and this will be a bool. Function L logger, and we create a log message, a log function. MSG will be a string. If L is nil, then we return. So this handles it gracefully. Like it makes sure that if you try to use this logger without it being initialized, then it will always it always return, as opposed to giving us that panic error, the runtime panic. So up for nil logger. As if verbose has been initialized, then we print out the message. Print MSG, and then let's use this in our, where's my cursor? Okay, let's use this main say var logger points to the logger, and remember this is uninitialized. Uninitialized. So here logger dot log, this can be anything. We're just gonna put something here. So starting scan, and the reason why we do this is just to show that it's safe to call this, safe to call here, because it's because if we didn't have this when we use this, we'll get an error. Let's try to see that. Let's just try to run it like this. Go run .main. See, it's because we're trying to use it and it's not initialized. But if we do it here, then it'll just give us back nothing, because it returns nothing. So, but we want to continue. We say logger equals, and then logger verbose, we're going to set it to be true. Then logger.log, and now we can put some message, scan complete, and then we can see it go. Boom. So it worked. All right. So common pitfalls for Nil receivers, unintended panics. For getting to handle the Nil, for getting to handle this, it will produce runtime errors. Now let's go on to explain value versus pointer receivers. And let's just go ahead and create our folder for that. Value pointers. Yeah. Main.go. And let's close all of this out except for this one. So in Go, a method can be defined with either value receivers or pointer receivers, and the choice impacts how the method interacts with the receiver, the instance of the struct. So we should have kind of kept that. So in this case, like what it's saying is that these methods can be defined with a pointer or just with a value, and we'll see an example. In this example, we're using a pointer, and having this indicates that it's a pointer. And when you have a pointer, you have to call it, or like like modified, or use it with this command, like with this So this method is trying to say is this method can be a value type or a pointer type, right? And the way you use it, the way you define it depends on your use case. So let's create an example. We'll say package main, and then we'll say type CLI context, struct, config path, string, verbose, bool, and then we'll say this is a method with a value receiver. Font C CLI context inspect attempt to modify the copy c.config config path equals modified path dot YAML, and we'll print that out. Print and we'll say inspect config path modified, and then we'll print out the config, and then we'll use this in main. This is the original context, CTX, CLI context. I keep doing that. Now we have to config path and then give that some path, config.yaml, and then verbose equals true. Then we can now print that out, format print line. And then we will say main config path, and let's just print out the whole context. And then we'll say call the value receiver method and CTX dot inspect. And so when we call this, we'll see this print out. And then when we try to call it again, notice the original CTX remains unchanged. That print after calling inspect, and from that print line main config path, and then print out the CTX again, and then the CD up to value go run main.go. And see, so this is what we have in the main up here, original, and then this print line here, and then we called it, so that's why we get this modified here, and then after we called it, we get this here. And so we see that we don't, in down here, we don't have that modified path. It's because we're using a value, and so a value, whenever we make changes, it's only local to here. Whether if it's a reference, then this is like a shared data structure, or like a shared context that when we make changes here, you can see it here, or if we make changes here, you can see it here if it's a reference. But in this case, we're using value pointer. So now let's use pointer. So we can use the same example. Let's just comment this out, and then we'll say func main and we'll say C. Well, we should have coming out everything. And I noticed I spelled that wrong too. But I'm gonna type everything over. I'm not gonna copy and paste. So this would be method with a pointer receiver. Okay, and this func. This is a reference now. CLI context update config path, and we'll say new path string c context config equals the new path. All right, and then now in our main, let's move this up so we can see. In our main, we have ctx equals config CLI context meant. And then we need to get out some values, config path and config.yaml verbose equals true. And then we say print line, and we be able to see those changes. Well, before we update it, we just see the regular original. Before update, and then we'll print that out. And then now we'll ctx.update, and we'll give it some new path. New config.yaml. And then now we'll say format print after update. And then we'll print it out. And then now let's look at this. So if you see, this is what it was before, and then this is what it is after, because we made that change, and we can see it. We can see it in main because this is a reference. So that is how you do reference and value. The last thing we want to discuss in this section is embedding. Let's make a folder. Can I make a folder? It won't let me. Why is it doing that? Okay. There we go. For embedding. Main.go. Package main. Okay. So embedding types in Go allows you to reuse functionality by including one type within another. In a CLI tool, this can simplify shared utilities like logging and scanning. So let's look at a quick example of embedding. So we say type logger struct, say verbose bool, and then now we have a func, and it'll be some method for log, and the MSG string, and we say if l.verbose. We should handle that too. Well, we don't have to do it right now. So fmt print line log I'm going to go ahead and do it. So if L is nil, then we'll just return. Get in the habit of doing it. Okay. And so now MSG, did I? Oh. Okay, so now we have that. We want to have a type. CLI context. And then we say logger. And this is the embedding. We can just, I spelled it wrong. Logger. I'm not really sure why it's not popping. This is it, but if I do that, that's fine. So here we are embedding this logger inside of this. That's pretty much all it is. And then now we can say config path equals a string. And we don't have to like redo all of that, right? And then so now we can use this. We can say func main. Something's wrong. Say like struct. Func main. CTX. CLI context. And so now we can set the logger. And then we can say a logger is verbose true. Now, I know that may look kind of crazy, but because we have the logger inside of this CLI context, then we now have it as like a key. And then the value of it is going to be, we have to set the whole type of the logger. So logger, and then we follow this verbose true. That's all it's saying. And then now config, missing one. Config path equals some random path fig.yaml. And then we don't, do we need that? Yeah, I guess so. Missing one. No, it's expected expression. So logger true. Then config path equals, oh no, let's just see. CTX dot log CLI tool. All right, so let's look at this. Oh, I am losing my brain. All right, so that's it. And we go run main.go. And pretty much it. It's really simple. It's simple, right? We now have this logger, this log function, this log method, because we have a logger, and this logger was embedded because we added it here, and we don't have to like recreate the structure in anything. That's pretty much it. That's it for this section. The next section, we're going to go over interfaces. Continue to watch, right? See you next video. All right, so let's continue where we left off at last time, and let's pick up with interfaces. So we'll come to our folder structure, and we'll say 5 interfaces, and we will make a subfolder called 1 basic interface. Let's give that a main.go and package main. Let's close everything and open this back up right here. Interfaces in Go provide a way to specify behavior without tying it to a specific implementation. For CLI tools, interfaces are invaluable for creating modular, extensible, and testable components. They allow for defining behavior that various parts of the tool can implement while enabling you to swap out implementations easily. Let's do a quick example. And then we will start with, we'll say type, scanner, interface. And we'll give it a method function that it has to, that everyone who abides by this would have to define, which is a scan, and returns a error. type file scanner, a strut, and then we say a path string, and then we'll create a function with a method. And this is a value method. fs file scanner, and then this is the method that it needs to have, and it returns the error. And so again, based on the structs that we just discussed earlier, this is a strut, and this is the method that goes with it, and this ties this method to here, which means that now it abides by the scanner, meaning this file scanner is a type of scanner. Dot print line scanning file at, and then we say fs dot path. Why is it not putting this in? Oh, because I don't have a comma. And now we say path. Okay, cool. And we need to return nil. Oh, we don't have main. So we need to create a type, another type, and it'll be directory scanner, and it's a strut, and it has a path string, and then it has type. No, func, and ds directory scanner, and scan method or function t.print line, and scanning directory ds.path, and then return nil. To use this, we will create another function called run scanner, and it accepts a scanner of type scanner, and if error scanner dot scan error is not equal to nil, then we print error. And so now we can instantiate different scanners. So now if we have, so we have a directory scanner and we have a file scanner, and they both satisfy the scanner interface, which is to have a function called scan, which they both have, and they return an error. And then so now we can have in our main, we can say file. This will be create scanners. So this would be our different scanners. And we have a file scanner. And we have to give it a path. It's a strut. So again, this is for the strut. So we need to do it like this. Path, and then some file.text. And then we say a directory scanner. And it's the same. Their scanner. It's the same as that. Directory scanner, strut, with a path, and configs. And then so now we can run the scanners. And then we say file, scanner, and I should have did that. Let me just write it instead of copy and pasting. Run scanner and dir scanner. And so again, what this does is it allows us to have this file scanner. Let me give it a name so you'll know. File scanner and directory scanner, and they both satisfy this interface because this is a strut and this is a method on that strut, and that method is called scan and it returns an error. And the same with this. This is the strut and this is the method for that strut, and it has a method, a function called scan, and it returns an error. So they both satisfy this. So now when I use this here, if it accepts a scanner type, which both of these do, both of these satisfy that type, I can now pass either of those into this run scanner, and it'll dynamically, choose it. It's like if you're coming from Java, like this would make sense, like polymorphism. Yeah, it's the same. So, and then so now we can save that and run it. So now we see scanning files at scanning directory at this. So that's that. Now we want to let's talk about interface conversion and type assertion. Go allows you to extract specific types from interfaces dynamically. This is something really I found interesting. So we call it conversion. And we'll say main.go package main. And so now we'll say func process value interface. So we pass an empty interface in, and it will dynamically be able to pick which one, like the type. Okay, equals value dot string. Well, string, and okay. And then we're going to print this out. Print line. String value str else. So basically we're saying if the type is a string, then we'll print out as a string. Else, if it's anything else, we'll just say not a string or something like that. Value is not a string. And then so now we can come here, and in our func main, we can say process, and we can say hello CLI. And this would of course be a string, and then we could say process 1, 2, 3. And then if we come up here, conversion go run main.go, we can see that at runtime, it was able to dynamically see what that type was. Right. So I think that's interesting. It's pretty cool. And the last thing we'll do is mock implementation. So it's 3. Let me say mocks. So in Go, interfaces are powerful tools for testing because they enable you to create mock implementations that mimic the behavior of actual implementations. This is particularly useful for isolating and testing specific parts of the code without relying on external dependencies such as file systems or network connections. Mock implementation provides controlled environment for testing, making it easier to simulate edge cases, failures, and unexpected behavior. And so we're just going to jump right into the example. Main.go. And we want to package main, say define the scanner interface. And if you're wondering where I'm reading from, these are notes that I've taken as I've read several books and stuff like that. And of course, talk to ChatGPT, and I wrote notes and stuff. So that's where it's coming from. Like, this is not coming from a book or anything that you probably have read or you can get. Interface. These are my own examples. Error. And then we have a mock implementation of the scanner interface. Type mock scanner and struct. Just leave it empty for now. And then we'll say simulate a successful scan. Font. And then we do it as value mock scanner. I cannot write scan. And it returns an error. Format print line. Scanning. And then we return the nil. And then we simulate a failing scan. Type simulate a scan failure. Return FMT error of mock scan failed. And then now to use this, we need to, let's say, generalized function to run a scanner. So it's generalized because it can accept anything that is of type scanner. Run scanner, takes a scanner of scanner, and then if error, and when calling the scanner, yeah, I was right. Scanner.scan, and error is not equals to nil. Then format print line error, then print out the error, and then we return to break out the logic, and then we say format print line scan completed successfully. And then we can use this in our main. Func main. And then we say test with the successful mock scan. And let's do another one test with the failing mock scan. And then here we say FMT print line to give us a message running mock scanner. Let's make this one word. And mock scanner. Is equal to mock scanner. So what do we get back from that? Then we're going to run the scanner on that. Missing argument and conversion to mock scanner. All right, let's keep going for now. Like we'll come back to that. Oh, that's why. Because this is a struct. Keep forgetting. So this is a struct. It's not a function. That's something I'm going to have to get used to. Avoid the mistakes that I'm making. Failing. Okay, cool. And then let's go up to mocks and go run main.go. Boom. So we get it. Error mock scan failed. All right, and that is how you do mocks. This demonstrates the runner scanner successfully works with the mock scanner, validating its behavior without needing real files or directories. So this tests those functions if it was real without having to access any real implementations or any real like directories or files. All right, so that concludes this section. The next section we're going to look at, and it's going to be really short, is error handling. And then we'll be on our way to more advanced concepts such as Goroutines and concurrency. And then after those two sections, we'll actually start on the project, which is what I'm excited to look for. So thanks for watching. See you in the next video. All right, so let's continue and let's move on to error handling. We'll say 6, error handling. So let's set up 1 basic and go main.go, package main. And here we will say func divide a, b, int, both are ints. And then this takes an integer and it returns an error. If b equals 0, then b is the second, so you know you can't divide by a 0, so we return 0 for the first value, and then errors dot new, we say division by 0. And then we return a, or if it's not an error, if it doesn't, if just the second one doesn't equal 0, then we can just divide it, a divided by b, and then return nil for the error. And then do our func main, result, and error, divide. And then for the first one, we can just say 10 and 2. So we know that won't produce an error. Error is not equals to nil. Then ft print line. error, and then print the error. Else t print line results set error divide, and then we can say this is 10 and 0, so we know this will produce an error. And then say if error not equals nil, then we'll say fmt print the error, print line and then print the error. Else print the results, print the results, and then the result. All right, so now let's give this a whirl. We cd up to, let's cd up twice and go to error handling, and then basic, go run main.go. And we can see the first one was 5, which is correct, and then the next one it gives us this error. So now let's go on to custom error, and let's create a main.go. So in Go, you can create your own custom error types to provide more context about the error. So it's going to be something simple. Package main. We say type divide error, and it's a struct. And we say numerator, which is an int. And maybe I should tab. And then we say denominator, and then int, and then message, and then that's a string. And then we say func. We're going to make a method for this, which will be pointer divide error, and we have this error function, and it returns a string, and it's return fmt, and we put the string format for that, which is error %s, and then %d divided by %d, and then say e.message, e.numerator, and then e.denominator. And then so now we say func divide a, b of integers, and it returns an integer and an error. 0, return integer, and the reference would be, so we need to give this a numerator, so it'll be a, and then the denominator would be b, and then the message would be cannot divide by 0. Else return A divided by B and return nil for the error. We say func main. We say error because we don't need the integer. Divide 10 0, and if error is not equal to nil, then we say t print line, and we print out the error. So now let's give this a whirl and custom go run main.go. And so we get that the custom error, and it gives us the message first, and then the numerator and the denominator. So that's how you do that. The next one was the defer, which is for cleanup, and we've already discussed that one, so we're not going to go over that anymore. Let me show you an example of panic and recover. So panic and recover are discouraged for normal errors. These are reserved for unexpected severe errors that are not part of the normal program flow. Use panic sparingly. Example: a corrupted memory, a missing configuration that must exit, and use recover and defer to gracefully handle the panic and resume execution if necessary. Panic and recovery are used for handling unexpected situations. Panic and recovery are used for handling unexpected situations, while panic is typically discouraged for routine errors. Is useful for truly exceptional cases such as a programmer's error or unrecoverable states. All right, my cursor gets stuck sometime. 3, panic. Just keep it as panic. And we'll say main.go, package main, func safe divide, a b or ints, and defer func if r in this recover r is not equals to nil, then we print recovered from panic, and then we print out the R, and then we're gonna automatically execute that. If you're coming from like JavaScript, that would make sense. Print, why is this not allowing me to do that? Am I missing something? Oh, func. Okay. t.print. A divided by B. And then now func main. Say save divide. And we'll do a good one. Then a bad one. Save divide 10 divided by 0. And so what will happen is this will, of course, run at the end. And it will make sure it always runs. And if there is an error, it will recover from the error. And so you will see. So we come back up, panic, go run main.go. So the first one did well. That's why we got this. And then the next one was by 0. So if you notice, like if we don't have this recover as the other ones, it will give us an error, cannot divide by 0. So let's just let's see how it would work if we don't have this. Well, that won't really work because we don't have an error, but let's just try it and see. Yeah, so that won't work. But anyway, so you get the point. That's pretty much it for that. The last thing we want to cover is wrapping and unwrapping. In Go, errors are values, and wrapping errors allows you to add additional context to them. This is useful for debugging and tracing the source of an error in a multi-layered application where errors might propagate through multiple functions. Go provides built-in support for wrapping and unwrapping error using the error F function and the errors packages. Why wrapping? It provides additional context. Wrapping errors lets you add context to your error messaging, making them easier to understand and understand the cause and where it occurred. When errors propagate through multiple layers, unwrapping allows you to access the original error for debugging and logging. And we will see an example. So we come up and we'll say for wrapping. Main.go package main. So here we will add some comments. So we simulate a function that generates a base error. And then we say func read file name string, returns an error. And if file name is blank, then we return errors.new, and then we give it a name of a message. File name is empty, and then we return nil. All right, so now we say simulate a higher level function that wraps the error. And so now we say func process file name string return error, say error, and we call that function above, and we pass it in the file name. And if error not equals nil, then we want to return that error. No, it's my bad. I want to return fmt dot error of, and then this will be process file failed to read file, and then let's pass in the name of it, and then no, we pass in the error. My apologies. So this is the wrapped error. So let me put the comment there. The error, then we return nil. If not, then let's use this in the main. Simulate failing case, and then we say if error is not nil, then format print error, and then the error. Oh, missing something. Process file. So we're going to pass in a blank error. So this is the simulate failing case. So now we print out the error, and then now we need to unwrap it. error to see the original error. It was like original error was errors dot unwrap, and then we pass in the error. And then format dot print, and then we say original error, then original error, and then let's go up and go run main.go. And so this is the error that we got because it's custom. So we have a custom error that we wrapped, and fail to read file name is empty. So this was a message that we put in from here because it threw this error. So when it throws an error, we caught it here, and then we wrap that error here. And so now we can see in the original error, we can see that original error message here. And so again, that's useful for debugging and tracing. So, and so that is it for this. The next section is the section we're going to get into concurrency. All right. So thanks for watching. Look forward to see you in the next video. All right. So let's continue. Now this section here is Goroutines. We'll say 7 Goroutines. And of course the first one, like usual, will be basic. So we say 1 basic. And then I'll say main.go. Now, what are Goroutines? A Goroutine is a lightweight, cost-efficient thread managed by Go runtime, allowing functions or methods to execute concurrently. The program starts with the main. So the program starts with the main Goroutine, which is the main, which runs in the main function. Additional Goroutines can be created using the Go keyword, enabling parallel execution of tasks. Goroutines are created by prefixing the function or method call with the Go keyword. Unlike regular function calls, Goroutines can run concurrently with this. And just show you a code snippet, but instead of showing that code snippet, let's just go ahead and run a real example. Say package main func scan file string wg sync dot wait group, and I'm gonna explain all of the code to you. So don't worry if you see some things that just doesn't make sense to you. By the end of this chapter, you will understand everything clearly. So we'll say mark this Go routine. Did I spell it right? Yeah. As done when exit. And then fmt print f. Printf, and scanning file s new line and then we'll just say file. Okay, and so now we're going to simulate scanning logic, and so that would just be time dot sleep, and then we'll say 1 second, time dot second, and then print f completed scanning %s new line, and then the file. Func main Forget the parentheses. Files is slice, string slice. No, it's not. Yes, it is. And so we say file1 dot YAML, file2 dot YAML, then file3 dot YAML. Then var, this is the wait group that we're going to pass in. It's a sync dot wait group, and this wait group to track completion of Go routine. And for, and then file in the range of files, wait group dot add, so we add 1 second to it, and then this would be increment the wait group counter for each Go routine. And then we do Go. And so this, in front of the scan file, this is where we put in the keyword Go to create another Go routine. So it'll run concurrently when the main runs. And then so we say file, we need to pass it in file, and then this wait group, but we're passing the pointer to this wait group. And then wait group dot wait. This will block. This will block until Go routine has completed. Has finished. We say has finished. The FMT print line. All files scanned. Then now we come here. We go up. I think we go up twice. And go run main.go. All right. Missing. Okay, so scan file missing. This is the reason, because I have it twice. It should only be once. Okay, so that's what it was. It's because so this was in here twice. Just remove that, and then you'll figure it out. Cool. So an explanation of the wait group. This sync wait group here is a synchronization primitive in Go that helps manage and coordinate multiple Go routines. It ensures that the main program does not proceed until the Go routine is tracked and have finished executing. Some things to keep in mind: avoid excessive Go routines. While Go routines are lightweight, creating too many can strain your system resources. Handle errors gracefully. Avoid race conditions by using synchronization primitive like sync mutex or automatic operations to protect shared resources. And we'll show some examples of that in a minute. And don't forget WaitGroup.done. So failing a call done can result in a wait group deadlock. So if we don't call the done, if we don't do this, then it'll just be waiting there. So now let's move on to showing a example of concurrent logging. So we'll say concurrent logging. And then we'll do main.go. In a CLI tool, you may need to log messages while processing tasks or files concurrently. However, when multiple Go routines log messages simultaneously, the output can become jumbled due to the unsynchronized access to the shared resources, like standard out. So in this case, in the very end, we will put it all together and make an example pipeline. It'll be really cool. So now we're just going to say package main and say logger synchronize this log messages using mutex. And then so we say type logger struct, and then it's mu sync dot mutex, and then func l logger, then log accepts a message string, and then we say lmu dot lock and put a comment next to this. So what this does, this is acquires the lock, acquire lock to prevent race condition. All right, and then we're going to defer the unlock, defer l dot mu dot unlock. So this we'll defer this until the end. So if whenever this function finishes, it'll always unlock it and release the lock. And say mmt print line, and we'll say log, and then we'll log that message. And then so now we say func main, and then we say logger equals, and then we pass it in. We use the pointer so we can have a shared resource. So this is shared logger instance, and then we say var WaitGroup sync dot WaitGroup, and then we say we create tasks, and this is a slice of string, and it's task 1, task 2, task 3. And then we say for task range and of task, WaitGroup dot add. So every time we increment, so let's say increment by a second, we add a Goroutine to the WaitGroup. That's fine. No, I spelled it wrong. Okay, and now we say go func, and then we say task. So why did it just make up that task string? I mean, although we needed it, but I didn't want it to do it. And then we defer and WaitGroup dot done. Dot done. Need to say done. And then we mark, this is mark Goroutine as done. Logger dot log. And then we say processing. And then task. And then pass that task in to the defer. You remember how we did this earlier in the example, so you should be familiar with this. WaitGroup dot wait, and this will wait for all Goroutines to complete. T print line. All tasks completed. And so basically, this is similar to the one that we just did. The difference of it is we're using a mutex so we can share this logger resource because of what we just said. Due to the race conditions, we want to synchronize those by using a mutex. So now let's run this and see how it goes. CD and say go run main.go. All right, there we go. And so if whenever this should have been task 3. 1, 2, 3. Okay, so I think the problem of it is this here. I didn't pass in the right word task. Okay, so there we go. Now trying to see if it'll print out a different order. Yeah, so if you notice, it could print out in different order. So 3, 2, 1, 3, 1, 2, 3, 1, 2. So if we get another one, 3, 1, 2, 3, 1, 2, 3, 2, 1. Yep. So another example that I want to show is adding cancellation. So the context package is essential for managing cancellation timeouts and deadlock in concurrent operation. It allows you to control long running tasks, which is particularly useful for CLI tools that interact with external systems like API calls or file scanning. All right, so we're going to come here and V3 cancellation. Go. So we'll say package main, and then we'll say func scan file ctx context and then we say file string, and then we say scan time.duration, and we'll make it a random time. And the reason why we're making this random is because so we'll see how when we run 3 files, if the time finishes before all processes get complete, then that one or two, whatever that didn't get complete, will get canceled out. And so by giving it a random time, they'll all have different times to complete. So three, maybe I should put a 2, but that's okay. We just for now. What this is doing is just giving it from 1 to 3 seconds times time.second. And this is random scan time from 1 to 3 seconds. All right, then we'll say select. And I'm going to go over the select later, so don't worry about it now. I'm going to go over this key word here that you don't even know about, but I'll go over that too. Printf scan s and took the v in new line file scan time. All right. So why is, because I don't have a comma. That's why. And then another case. And basically what this is, like there's 3 operations. One where you send, one where you receive, and one where you wait. This here is a wait we're waiting until after that time. But again, I will explain it more later. Go scan file, CTX, and then file. And then I think I'm not sure if I did this right. Math.random time duration ran 10 3 plus 1. Oh, I'm missing that. That's why. It's supposed to go here. Yep, that's what it was. Okay, and then func main ran dot seed time dot now tx nano. When you use tx nano unix nano, yeah. And then in that, this seed for random scan times. Then CTX, cancel, and context dot with time out. And then this will be context dot background. And this is 2 times time dot second. Deferred cancel. So we want to cancel at the end. And this cancel is what we're going to be doing. Like, this is the whole point. In the files, string, in the file 1 dot YAML, file 2 dot YAML, and file 3 dot YAML. 3 dot YAML. And for file in the range of files, go scan file, pass in the CTX, and pass in the file. And then time.sleep, 3 seconds. This will allow time duration outputs. Time to observe output. Time to observe outputs. So basically this is just to give us time to like see. So don't worry about that either. I will explain everything. Main function exiting. All right, so let's run this. Go run main.go. Okay, so I think the problem of it is this here was not supposed to be here. I am totally messing up, y'all. This is supposed to be dot print cancel. You will never see it if it doesn't get canceled, because I'm doing another Goroutine. What am I doing? All right, it's getting late. I need to go lay down or something. All right, so let's look over this code and make sure I got this right. So for this case, so on this first case, whenever it comes through, it's going to wait for this time after this 2 seconds that we give it. And whatever files get processed within those 2 seconds will come here. After that 2 seconds, it'll execute this. This is like a switch case, but it's called a select, and it's used for channels. But don't worry about that right now. And so after that 2 seconds, whatever process didn't get filled or didn't get processed will come to this case here, and then that's when you will see that cancel. We didn't see that cancel because I had different code that it wasn't supposed to be there. Let's check this and see. All right, so let's try one more time. Yeah, so if you see this one here, it took one second. This one here got canceled, and then this one here took 2 seconds. So this took 1 second, this took 2 seconds, and this one obviously took longer than 2 seconds. That's why it got canceled. And again, the order it won't show up in the right order. That's just the way it is. Context of course, this is the 2 seconds, so we're giving it time to complete, which I've already explained that. We're processing. I mean, I think I've explained enough. I don't have to read this. Yeah, so I think I explained this too. This here is an operator in Go. It interacts with channels, enabling communication between Goroutines. Channels allow Goroutines to send and receive values, making it possible for the coordination and synchronization of concurrent tasks. So now let's go on and let's do a simple channel. And then we'll say main.go. Go. Let's just save this and then close everything out. All right, so what are channels? A channel in Go. Channels in Go are essential for managing communication and synchronization between Goroutines. In the context of the CLI tool, channels can be used to coordinate tasks like scanning files, aggregating results, and reporting progress in real time. A channel is a conduit for communication between Goroutines, enabling safe and efficient data sharing. It allows one Goroutine to send data while another Goroutine receives it. Channels are typed by the kind of data they transport. Example, a channel string or channel int or whatever. Channels are created using the make function. Unbuffered channels in Go are used to synchronize tasks by ensuring strict handoff between sending and receiving operations. They block the sender until the receiver is ready, making them ideal for managing deterministic or predictable task completion. Say package, main, and then func scan files, task, ch, and then this is a channel string, and done channel, and this is a channel, and this is a struct. And it's a for task in the range of task channel. This is what we're passing in. fmt.print line, scanning, and then we'll print the task out, and then we'll make it sleep sometime. The sleep would just be simulation of processing or scanning. Time to sleep. And we'll let it do it for 1 second. Time.second. Relate scan time. Then we say done channel. And this will let us signal signal completion. So this will pass the struct to the done, signaling the complete. So whatever we pass in here, we'll pass it to here to signal a struct like it's done. Say, hey, this is done, because this right here is sending in like an empty. I believe that's how it works. Yeah. Completion. func main task equals make. And if you remember this make that we did earlier, any time we want to use a shared resource or shared data structure, we use the make keyword. So we're making a channel string, and we're sharing this channel. So that's why we're using the keyword. So this is a channel for file paths, and then we have one for done, and we make a channel, a struct, and then this channel to signal worker completion. And we say go scan files, and then we're going to pass the task and done. And then this start the worker go routine. And then we say task. We're going to pass it a path to some file 1. We send task to the worker, and we just double that because it'll be file 2. I know so we're going to copy and paste, but hey, that's the only thing. And then we're going to close it. This closes the channel. To signal no more task. And then we say done, fmt dot print line, all files scan. And let's see how that works. Go run main.go. Bam. Good job. So we have these two channels that we can listen to. One is a task channel and one is a done channel. We're going to call go, which is a go routine, to like start in another worker to be, executed. And then that means we're going to start this process here via a go routine. So simultaneously, we're both going to be running, and we can talk to each other via these channels. We're going to pass in this data to this function here to have it to process. So it's going to iterate over it 2 times, and it's going to sleep for 1 second. And then after it's done, it's going to execute this and signal, say, hey, done, I am done. And so when it sends this to here via this channel, we know that we can listen to it on this channel because all this says is done. This is just the done that we created here. And so when we listen to it on this channel, we're going to receive that. And we're like, oh, okay, he's done. Now let me print this out. And so that's why you get it executed these two via this. And then at the very end, it said all files were complete. If that didn't make sense to you, just keep on watching. It will be clear at the very end, I promise you. So now let's move on to this, and we'll say 5 pipeline main.go package main, and then now we'll say func read task. And I think this will make it clear for you. If you're still having problems, I think this will make it clear for you, because it helped me understand it. So I equals 1, I less than 5, and I plus plus. Dot sprint f file %d .txt, and then we got and then this will send tasks into the channel. And then now we close that task channel. It should be task ch, not task chn. Let me remove that. And then now add a comment for here. So this signal, no more tasks. And this is similar to what we just did. So func scan task, task ch, and then chan string result channel chan string for task in the range. No, I'm thinking about task ch result channel will receive fmt dot sprint f scanned %s task. This send results downstream. Then we close that result channel. And then finally the main. And so we create our task, our channels. One is the task channel, and it's chan string. And then we send the value 5. So we're making a channel of 5 tasks. And this is a buffered channel for a task. And then we say results equals make, and we make another channel string of 5 as well, buffered channel for results. And again, buffer channels allow sending and receiving to operate independently until the buffer is full. So we have our channel set up. We're going to say go read task, and we'll pass in the task. And this is stage 1. Let's write a comment for that. Stage 1 task producer. And then go scan task, and we'll have task and results. This is stage 2. Stage 2. Stage 2, and this is task processing. Okay, and then now we say stage 3, and this is for consume the results. All right, so this is the consumer. This will receive everything. And so now results range result. Print line, and then result. All right. So let's look at this, and then I will walk it step by step how it works. Promise you that. Let's get to go first. All right. So you don't really see a difference, but file 1, 2, 3, 4. Did I pass in 4? So it'd be 5. Oh, greater than equals to 5. Okay, there we go. So now let me pull out this. All right, so let me kind of go over the code and then I go. So there's 3 stages. There's stage 1 where we read the task. There's stage 2 where we scan, and then there's stage 3 where we like print it out or display. When we first start, we're making a channel so that we can talk on those channels. And in this, we're saying, hey, there's 5 items in this channel, 5 items in this channel here. And now we're going to send that task, that channel, to this read task. And so we're going to send a task to read, and we're going to send a task to scan. And we're going to send only the results to the scan. But in the main, we also have the results. So whenever we send this is going to take those 5 that we just created. And so now we're going to iterate over 5 times, and we're going to create 5 messages. That's file.text. And we're going to pass them or like broadcast it out on this channel here. It says, hey, I'm creating 5 different strings, which is file.text, whatever. And I'm blasting it out on this channel. So whoever can listen on this channel, you will also get it, because this is, remember, this operator is a receive. So it's receiving this the string here on this channel. And then at the very end, it's going to close it. So now there's 2 messages that went on this channel. One was to send the task, and the other one was to close. And so now that we closed it, all this does is just like trigger this, and it just says, hey, I'm done, so you can stop. You know, there will be no more. You don't have to keep listening. And so what's happening is now the scan will also get these 5 task channels that these 5 strings that we just created, and it'll iterate over those 5, and it'll also it'll add to that string scan. Now I'm scanning that task, and that task comes from this channel here, which is just this string here. And so we're concatenating scan with this task, and then we're sending it on the results channel. And this, again, operator lets it know this is a receive. So this receive channel will receive these 5 messages, because we have 5, because we just iterate over the range of this, and this comes from here, right? And so at the end, it says, hey, close me, I'm done. Boom. We don't need no more. And so when this is closed, it now can talk on the result channel to here, and the for loop says, okay, now that you're done, I don't have to wait no more. I don't have to listen no more. I can now iterate through, and that's why you get to see these print statements. So I hope that was clear. We have one more thing to go over, and that is the select. And we've already actually seen the select. Oh, well, so I want to mention, to enforce clear responsibilities, you can also create a unidirectional channel that can be used for sending and receiving. So you can do that. We're not going to do that now. There's an advanced pattern in channels called fan out, fan in. Fan out, multiple Goroutines consume tasks from a single channel. Fan in, results from multiple Goroutines are aggregated into one single channel. So I'm not going to go over that, but just keep in mind that does exist. And the one that I'm going to go over is the select statement. We've already seen it, actually, so I don't really have to go over it. We went over it. Yeah, I mean, I don't mind. I don't mind going over it. But we did it before. It's just like a switch statement, but it's a switch statement for channels. So 6, and we'll say select. And then we'll say main.go. I know this video is getting pretty long. I want to kind of get through it, but So func main, we say it's channel 1, equals make chan string, and channel 2 make chan string, and then we simulate concurrent task, and we say go func time.sleep to times time.second, and simulate delay, and then the channel 1 will receive a message result from task 1, and then we'll just execute that. Then we'll do another go func, execute that too. Just go ahead and do it, and then we'll do the same sleep. That'll be 1 second time.second, and then this will simulate a quicker task, and this is channel 2. And so the purpose of this is to like demonstrate that simultaneously we can have these Goroutines, and which one is available, sooner is the one that will get the process. So use select to wait for whichever channel responds first. So we say select case response, and we listen for channel 1. And if we get it on channel 1, we say FMT print line, and just a response. And then we do another case response equals from channel 2, and then we say FMT dot print line response, and then we say case where it is time.after. So if it's longer than 3 seconds, time.second, then we do timeout, plot timeout, FMT t.print timed out waiting for task. Okay. And then now we go up and go run main.go. And so we got it for task 2 that time. Let's see if we ever get one for task 1. No, I don't think we'll ever get one for task 1 because task 2 is the one with the quicker time. Yep. So that pretty much is it. Like, this is the gist of how the select works. And so it says channel 1 and channel 2 are created to simulate 2 independent tasks. Goroutines send messages to these channels after a delay using sleep. The select statement listens to all the cases, and the final case. So case 1, it listens for channel 1. Case 2 listens for channel 2. Case 3, it triggers a timeout if neither channel sends a value within 3 seconds. First ready case wins. The select statement executes the first ready case. If channel 2 sends a value first, the case runs and the others are ignored if neither one or two receives. So I don't think case 1 will ever win, to be honest with you. We can keep trying, but it's not because the time that we have. And now if we would have did the random time for this, then it would have. But this here, let's try to see if we can do what happens if we do it for 2. See, case 1 won that time, and case 2 won that time. So yeah, so it shows you which one. And then now, if neither one of them, I mean, you will get the drift. This video is getting too long, so I'm gonna close it up now. But that was it for Goroutines and channels. I hope that was clear. If not, drop a comment and drop a question in the comments below, or reach out to me on my email, and I will respond. I will respond. The next chapter we're going to go into is going to be even longer, so I might break it up, but it's going to be over concurrency. Then again, after that, we're going to go quickly after that, maybe over Cobra, or if not, we're just going to just jump right into the project. So, because I'm ready to get my hands on with that. So, all right, thanks for watching. Look forward to seeing you in the next video. Bye. Concurrency in CLI tools often arises when handling tasks like scanning files, processing data, or generating reports in parallel. This section focuses on avoiding race conditions when managing shared variables across multiple Goroutines in a CLI tool. Key concepts in concurrency. Concurrency, safe functions, and types. A function is concurrency safe if it can safely access multiple Goroutines without additional synchronization. Types are concurrency safe if all of their methods are concurrency safe. Rule: access shared variables concurrently only if the types explicitly guarantees safety. Race conditions. Definition: a race condition occurs when multiple Goroutines access a variable concurrently, and at least one access modifies the variable. Race conditions lead to unpredictable behavior, especially in concurrent tasks like scanning and aggregating results in the CLI tool. Let's look at some ways to avoid race conditions in a CLI tool. So the first one is confinement to a single Goroutine. Restrict access to shared variables by confining them to a single Goroutine using channels to communicate with the Goroutine. So we're going to come here and we're going to say section or chapter 8. And then we'll just say concurrency. And then create a folder, and this would be confinement. It's a lot of different sections, so I might want to do a subsection of this. Let's say strategies first. And then inside of strategies, I have another folder called confinement. And then we create our main.go. Just close everything up. So we start with package main and func count manager count channel chan int and result channel chan int, and then we count initialize to 0 for val goes range of count channel, and then count increment the value plus equals value, and then we say result channel. This sends the final count to the channel. It's all familiar to you, so And then now in the main, we say count channel make chan int result channel make chan int, and then we say start the counter manager. We say go count manager, and we pass it those channels, count channel, result channel. Then we say paths is a slice array. A string slice of file 1, file 2, file 3. You var wait group sync dot wait group. Then we add the number of Goroutines. And I think earlier I actually said that this was incrementing, but what it does is it adds the number of Goroutines that we're going to have. So let me show you what I mean. For path, range of paths, and then this here is when we do wait group dot add. So if we have 2 Goroutines, we're going to add a 2, but because we only have 1, we're just going to add 1. So I said that wrong a little bit earlier, I believe. Let me say p string, and then we're going to defer the wait group dot done. Because this marks it as complete. Marks Goroutine as done. And then we fmt.printf scanning and %s new line p. And then we increment the count by sending the value 1, send increment to channel, and then pass in the path. And then now we say go. This will wait for all go routines to finish, then close the channel. Go func wait group dot wait, and then we close count channel. And then we print the final results. fmt.printf All right, let's run this and see. I was already in the folder, so just cd to that folder and go run main.go. All right. By confining a shared state like count variable to a single Go routine, you eliminate the need for explicit locks, avoiding race conditions entirely. The count manager function acts as a sole owner of the count variable, receiving updates through a channel and sending the final results back. This approach ensures safe sequential updates to the shared data while leveraging channels for communication, keeping the code simple, efficient, and concurrent safe. All right, so now we're going to look at another example of ways to avoid data races. The next one is mutual exclusion. The way it works is a mutex ensures that only one routine at a time can access or modify the variable, preventing race conditions. In this example, and I'm going to go over an example here, and then I'll explain it in the end. So we'll say to Mutex, and we've seen this before, so. We pass in that path, and then mutation lock, mutex lock. So scan the count, increment that, and then we unlock it. Once we're done, in func main pass is a slice. And then we create our wait group, sync, and wait group. And we say for path in range of paths. We add that wait group. So wait group dot add this one. Then we do the same thing. It's similar to what we just did. Func p string. We defer this wait group done. Then we need to pass in the path. And we also need to call scan file and pass it p. And then now wait group dot wait. This waits for all scans to complete, and then we can print it out. Print f total files scanned %d new line, and scan the count. And let's give this a try. Go run main.go. Cool. So three files are scanned. And the way this works is the mutex locks and the mutex unlocks creates a critical section around the scan count variable, making updates safe and sequential by combining sync mutex with sync wait group to manage the go routine. The program guarantees consistent results while processing tasks concurrently. So all this is, again, we've already seen this before, but by using this with the wait group, making it wait until everything completes, it makes it concurrent. All right, so the next one we're going to do is channels for synchronization. We've already seen channels, of course, but you're going to do another example. Channels provide a safe way to synchronize routines by coordinating access to shared data. Here the task manager, and we'll just go over the code and then we'll see. So instead of being this, we'll say channels, 3 channels, main.go. package main, func task manager, task ch, chan is a string, result th channel is also a string. And then for task range in task channel, result, I keep erasing it, fmt dot sprint, and processing. I think this is the same example that we saw before too. So task, it never hurts to write it again. It's muscle memory. Result. Then now we close that. And then we pass the result channel to signal the closure. And then task. And we make this channel string 3. Make chan string 3. Go task manager, we pass in the task and the results. And then we create our paths. File 1, file 2, file 3, 4 path, and the range of paths. Then task, get the path, task, because we send it to the channel, send the path to the channel. Then we close it and signal to the task channel that we're done. And then for result, in the range of results, this results channel. So we're going to iterate through the results channel and just print out all the results. And then let's see this. Go run main.go. Bam. And of course, we've seen this before, but again, this approach here, the task manager function receives tasks from the channel, processing them and sending results to another channel. This approach avoids direct access to shared variables and ensures data integrity by communicating through channels, keeping the program both safe and easy to understand. All right, so one more, well, we have two more, but another way to do this is serial confinement. And we create our main.go. So transfer ownership of a variable through channels to ensure that only one Goroutine access them at a time. Serial confinement ensures that a single Goroutine has exclusive ownership of a variable at any given time by transferring it through channels. And then we'll see an example. So package main, and then type task struct, and we say path. Let's do a string, and then state string, and func scanner task channel receives a task, and paths is a string slice. And for path, and path in the range in the paths. Task will receive that task. And we say the path will be that, and the state will be scanned. And then we close that channel. Not clear, close. So I'm going to close that task channel. And this should be task because this is the channel. All right, so function reporter. It also accepts a task channel, and then result channel equals a string. So that's what we'll see. I'm sure we're gonna pass in the results. And for task in the range of tasks, again, we iterate through, and then results. This is we're gonna send our message to a string message report. S is S task.path and task.state. And then we close that result channel. And then func main. Then task, create that channel, make channel as a task. Then results. We make this as well as a channel. I believe it's a string. Yeah, string. And then pass would be a string slice. File 1. File 2. And file 3. Then we create 2 Goroutines. Go scanner, and then we pass in the task and the paths. And then we do another one for reporter, and we pass in the task and the results. And then for results, gonna iterate over that. Range and results. Then we're just going to print that out. Result. And then let's give this a go. CD. Yeah, and it's done. So report file is scanned. All right, so in this example, the scanner Goroutine sends ownership of tasks to the reporter. So the scanner sends the ownership of the task to the reporter Goroutine, which processes and reports them. By avoiding simultaneous access to the shared variable, this method guarantees safety while enabling concurrent processing in a controlled sequential manner. So again, the way it works is we first send this task to both the reporter, and so this channel to both the reporter and the scanner, and then here we're going to pass in the path so that it can scan them. And then when it's done, it's going to send out and say, hey, I'm done. Like, well, again, broadcast on the task, say, hey, I'm done. And the reporter will now pick it up because it'll see the task and it'll see that this is done. So it'll start its process. And then the same thing will happen. Once the results is done, it'll print out its final, say so, and then close that channel. And then this for loop will notice that, we'll get that signal and then begin this iteration. So, all right. So in this last example, it is the worker pool pattern, and we will say 5 worker pool pattern, and then we'll say main.go. let's close all this other stuff out the way. And then we'll begin package main. Worker pool pattern is a common approach for managing resources usage efficiently. It allows you to limit the number of Goroutines running concurrently, which are useful for tasks like scanning or API requests in a CLI tool. So now we have our func and then a bit of worker, ID, int, task, channel, string, and then we send the results as well. Results, channel, this will be a string, and then we send a wait group with a pointer to the wait group, sync.waitGroup, and then we're going to defer the wait group and say done once it's done. For task, in the range of tasks, results will receive this printf, worker D process, and then S, and then ID, and then task. And then we have a func main, task, make, channel string, 10, results, make, channel string, then 10, then var wait group, sync.waitGroup. And then we start a fixed number of workers. Number, let's call it num worker, equals 3. For I equals 1, less than or equals to num workers, I plus plus. And then we say wait group dot add. We want to have one go routine, so we add one go worker, and we pass in the I, tasks, results, and then the pointer to this wait group. Then we send some tasks. Go func. Oh, not inside of here. Outside of here. All right. Go func. And it doesn't need anything, so we say for I equals 1, less than equals to 5, I plus plus. And then we say task. We receive a message from t.sprint. And we say task %d, and then I. Then we close that. Task. Then we execute that. And then we wait for workers to finish and close results. Go func. And then we say wait group dot wait. Then we say close results. And then we collect the results. For this range of results, we're just going to print that out. All right, let's give it a go. Go main.go. Go run main.go. All right, so it processed them all. So the worker pool pattern limits the number of concurrent Goroutines, efficiently managing resources while processing tasks. A fixed number of worker Goroutines receive tasks from a shared channel, processing them and sending the results and output channel. This approach assures that the system doesn't get overwhelmed by too many Goroutines, making it ideal for tasks like scanning or API results in the CLI tool. The sync wait group ensures all workers completed before the results channel is closed, keeping the workflow controlled and predictable. So that was the final example. The next section will be about error handling. All right, so in this next section, we're talking about error handling in concurrent programs. Handling errors from multiple Goroutines is often overlooked, but is critical for building robust concurrent systems. Combine channels with error propagation to ensure errors are collected and handled properly. And we'll see an example right here. So let's come and go up to Concurrency and make a folder to error handling. And then we can close strategies and we'll say main.go. And let's start with our package main. And we'll say func worker ID int, and then results. It's a channel, a string, and errors channel. Am I saying channel for the other one? Results. That's fine. Errors channel, error channel, and it is a channel, and it is an error. And then with a wait group, a pointer to the sync dot wait group. Then again, similar to the last code, defer the wait group. And then if ID equals 2, we'll send the error message to the error channel. Send error dot new, and we'll say worker 2 encountered an error. And let's just explain what this give a comment. Simulate an error for worker 2. All right. And then we need to return this so we break out of the condition. And then we say results. We'll get that in fmt.sprint f, say worker D completed successfully. ID. And then so now main for WG sync dot wait group, sync dot wait group. And then we create our channels, results equals make channel string 3, and then errors channel equals make channel error, and this is also 3. And then we start the workers for I1, and then I less than 3, less than or equals to 3, I plus plus. And then we say wait group dot add one Goroutine, and then go worker, we pass in the I, then we pass in the results, and we pass in the errors channel, and we pass in the wait group. And then we wait for the workers and close channels. So we say go func wait group dot close. No, wait, we gotta wait. Then we close. We'll close the results channel, and then we close. Yeah, I'm aware that I got that spelled wrong, so I need to change it from clear to close. All right, and then now we execute that. And then we collect results and errors. So we say for results, this is from range in the results channel, and we just print that fmt.print results. Then we do the same thing for errors. Error in range of errors, error channel, and that print line. And then we say errors, error, and then we print the error. And then let's go check it that. We need to go up one more. Main.go. And we see that we get 1 and 3 successfully completed, but error 3 was propagated to the main, saying that it encountered an error. So that's how you do that. So this approach combines channels and error propagation to safely handle errors from multiple Goroutines. Workers send successful results to the results channel and errors to a separate errors channel, ensuring errors are captured without interrupting other workers. By using sync wait group to synchronize all Goroutines, the program guarantees that all results and errors are processed before the channels are closed. This method provides a robust way to manage and report errors in a concurrent system, making it ideal for CLI tools that process multiple tasks simultaneously. All right, so we are moving along pretty fast. The next section is deadlock detection. While Go handles many concurrent concerns gracefully, deadlock still can occur. A deadlock occurs when 2 or more Goroutines are waiting for each other to release a resource, and none of them can proceed. Deadlocks typically happens when multiple Goroutines acquire locks in an inconsistent order or blocks each other indefinitely. And let's give an example of how it looks and then how we can fix it. So we say 3 deadlock. We say type counter is a struct. We say sync.mutex, not map, .mutex. And then count is int. All right. And now we have a func C counter. So this is a method on that struct to increment it. And CMU.lock. Then deferred unlock. Defer C.mu.unlock. And then we C.increment the counter, C.count, increment it. Once it's done, func main and we say counter 1, and it's a struct, but it points to that struct. Counter, and then we say counter 2 is also point to that. Yeah, I think that's right. Var WaitGroup sync.WaitGroup sync.WaitGroup, and then we're going to add 2 this time. WaitGroup.add. We say 2 because we have 2 Goroutines, one for the counter 1 and one for counter 2. Well, 2 Goroutines that's trying to access these counters. And then say go routine 1 ACE acquires counter 1's lock, then tries to acquire counter 2's lock. So we say go func, and again we defer the close with the done. Counter 1.mu.lock. So FMT, so we're going to print out that we got the lock. So FM print line go routine 1 acquired lock on counter 1. Then we defer the unlock. Defer counter 1 dot unlock. And then we simulate some work. So we say FMT print line go routine 2 acquire lock on counter 2, and then we do the same for that. We defer the lock. Hold on, it's not right. Go routine 1 is trying to acquire a lock on counter 2. ACQUIRE. So now Goroutine has acquired the lock and it's going to defer, and while it's doing that, it's going to also try to count and get this lock from counter 2. And then we're going to say counter 2.mute. Why is it not? What am I did? Counter 2. Why we can't get counter 2? Did I spell it wrong? No. Okay, I think I see the issue. Counter 2 is not an actual, I didn't struct. Okay. So MU lock. And then we're going to say defer counter 2 that MU unlock. All right. And now we're going to do a similar thing. We're going to say go routine 2 acquires counter 2 lock. Then tries to acquire counter 1's lock. So we say go func and we defer WaitGroup.done, and then we say counter 2.mu.lock. So we first get counter 2's lock, then we defer to unlock counter 1.mu.unlock. No. And then we simulate some work, and we say FMT print line, of course, go routine 2 trying to acquire lock on counter 1. And then we say counter 1.mu.lock. Then we defer to unlock for counter 1 mu.unlock. Execute that. Wait. Print line. Say program completed. So let's go to that. Go run main.go, and we will get an error with this. All right, so we see what happened. First, go routine 2 trying to acquire lock on counter 1. Go routine 1 acquired counter 1's lock. So go routine 1 acquired its lock. Go routine 2 is trying to acquire this lock. Go routine 1 is trying to acquire this lock from 2. Then there's an error. Let me kind of explain this. So in this example, 2 go routines acquire locks on 2 shared resources, counter 1 and counter 2, but in the opposite order. Go routine acquires the lock on counter 1 and waits for counter 2, while go routine 2 acquires the lock on counter 2 and tries to wait for counter 1. Since both go routines are waiting for each other to release the locks, the program reached a deadlock. So the key thing is that they acquired the locks in opposite order. Go routine 1 has counter 1 and it's waiting for go routine to release it so it can get counter 2. Go routine 2 acquired counter 2, which is the one that go routine 1 is waiting for, and its go routine 2 is also waiting for go routine 1 to release lock 1, but go routine 1 can't release lock 1 because it's waiting for go routine 2. And if you can see that, it's like I should have drew a diagram, but that is what the problem of it is. So to fix this error, all we need to do is come here and make it the same order. So we say 1, and then this will be 2. 1, and then 2. And then now let's run that. Now it's completed. So again, the problem was when this one acquired lock counter 1, and then it was trying to get counter 2. It couldn't get this one because this one had acquired counter 2, and so while it couldn't get it, it's just waiting for this one to release this counter 2, because this was a counter 2, if you remember, right? Yeah. So this one acquired lock 1, and it was waiting for lock 2. This one acquired lock 2, and it's waiting for this one to release lock 1, but this one can't release lock 1 because it's waiting for lock 2, and this one can't release lock 2 because it's waiting for lock 1. So the way you fix that is to make sure that when you acquire the locks for each Goroutine, you acquire it in the same order for both Goroutines. So I found that kind of interesting, something to take a note of. The next section, well, that's it for this section. I'll see you in the next section. Okay, so in this next section, we're going to introduce the concepts of Cobra, which is a CLI framework in Go. Now, this won't be the end-to-end project that we will create using Cobra. This is just an introduction to it to give you a hands-on so you'll get familiar with it. I'm still going to, the next section will actually be the end-to-end project. And what I'm thinking about doing is just releasing this full tutorial out, and then in the next coming days, I'll be building the project and creating the videos for that. The end-to-end project won't be as big, so like I don't want you to think that it's a huge project and that's why it's taking so long. The reason why I'm releasing it now without the end-to-end project is because so you can kind of start getting up to speed, and then by the time you finish with the core part, you'll be ready for the demo or the end-to-end, and that'll be the same time that I release it. So just kind of give you a note on that so you don't think that this Cobra section is the end-to-end and you don't think I'm not going to release the end-to-end. So what we want to do is let's close everything out. We want to come and we'll say section 9, Cobra. Cobra is a powerful and flexible library for building modern command line interfaces in Go. It provides a framework for creating commands, subcommands, and flags while adhering to POSIX standards. Cobra is widely used in tools like Hugo, Kubernetes, and many other popular Go projects. So the first thing we want to do to get started is install Cobra. So let's go to that folder. Need to go up to. And then you can just run. I mean, you don't have to be in the folder to install this command, but to run this command, but just do it anyways. Like I already have it, so I'm gonna run it again. It won't hurt. And then let's create this project. So we're going to have a folder called CMD, and then we'll have a main.go. And then in this CMD, this is just the commands. We'll have a root.go and a version.go. And so the root will be the command that you run, like it's the main command, and then the version is a sub command. So that's what we call the version. And you can, like, this doesn't have to be version, but for our commands, it's going to be a version command. So we'll have task as the root and then task version as the version. And so that's the way to go. So in our root, let's go to the root first. What we're going to do is say package cmd, and we want to say var root cmd equals reference to Cobra dot command, and then we say use. We want to give it a name. So this is the name. This is the short. Task CLI is a simple task manager. Then we get long, and this will be task CLI is a simple example driven task manager. Built with Cobra for demonstration purposes. And we got too many on that. And then we have the run. And this is the main execution. This is where the logic goes. So we have, this already gave it to us, args. Yep, it gave everything that we needed. Make sure our comma is here. And this is where we put the logic at. So we're just going to do a printout for our simple logic. Print line. Welcome to task CLI. And this is what you will see when you run the command task. Use help to see available commands. And then our func execute, this is what executes it. Execute. And then say if error, we want to handle the error first. In root command dot execute. An error is not equals to nil. Then we want to format print. Print line. That error. And then we exit. Just give it a number, a 1. It could be 2, but just do 1. And then so now we're going to go to our version command, package command, and we say var version cmd equals to Cobra dot command and then we say use, and this is the command that we use. Version, make sure I have lowercase for that. Yes. Okay. Version short, print the version number of task CLI. Then the run again. This is the main logic function. Let's do that again so we can get that. Yeah, I like that. And then we just do the same print line task CLI version 1.0.0 and then func init. This is where we attach this command to the root. So we say add command, and then we're going to add this version again. This attaches this sub command version to the root command. And then now in our main, what we want to do is just do package main, and then we say func main, and then we're going to call that CMD. It's going to pull it in from where whatever you created that mod, that's what it's going to pull in. So execute, and that should be it. So now to run this, just to give it a test, we could say go run main.go, and we'll get that out. But to run it the way we normally run command lines is we need to build it and then move it to our bin. So we say go build .o for out, and we're going to build a task. And so we should see that task there. And so now we can say sudo move task, and then we point it to our bin, sur user local bin, and now this will make it global. So we can call that command without anything. And so now if we say task, we get the same thing. And then so it says -help to see available commands. So we say help, and we get that. And then we can say task version, which is the subcommand, and we get the version. And we can also do task version .help and see the flags for the version. And that's pretty much it. To clean this up, what we want to do is, where's simple just go sudo rm that user sur local bin, and then the name of the task. And so now if you say which task, or if you just run task, you should get nothing. And you can say which task as well, and you'll get nothing. So that was it. That was a simple demonstration of how we can use Cobra. Cobra is a really cool tool. And the next chapter, we'll be going over the end-to-end project, which utilizes Cobra. All right, so stay tuned for that. Thanks for watching.